Here is the combined summary. Major depressive disorder, MDD, is a pervasive mental health condition affecting 300 million people worldwide, with a 27% increase in global prevalence due to the COVID-19 pandemic. Current diagnosis methods, relying on clinical interviews and self-reported inventories, are subjective and prone to bias, resulting in a high misdiagnosis rate. This work proposes a novel, Tri-Modal architecture that incorporates large language models, LLMs, to improve depression diagnosis from clinical interview recordings. The architecture utilizes Mel Frequency Cepstral Coefficients, MFCCs, facial action units, FAUs, and a two-shot learning-based GPT-4 model to process text data. MFCCs provide a compact representation of human perception of sound, allowing for the low-level representation of timbre, pitch, and rhythm. FAUs, a low-level representation of facial muscle movements, are effective for effective computing tasks. The proposed architecture outperforms baseline and state-of-the-art models on the DAIC-WOZ AVEC 2016 challenge dataset and leave one subject out cross-validation, achieving an accuracy of 91.01%, F1 score of 85.95%, precision of 80%, and recall of 92.86%. This work demonstrates the effectiveness of LLMs in multimodal architectures for mental health diagnosis and highlights the potential of such architectures in classifying depressed patients. In the context of multimodal depression diagnosis, data fusion strategies play a crucial role in integrating information from different modalities. Model-level fusion, which combines individual modalities before concatenation and further processing, is the most commonly used and best-performing fusion method for this task. The DAIC-WOZ dataset required pre-processing steps to resolve errors, including regex and NLP techniques to correct grammatical errors and adjust speaker names for clarity. Text pre-processing involved converting CSV files into raw text data, merging subsequent utterances by the same speaker, and diarizing speakers. Audio pre-processing stages included segmenting audio to include only patient speech, augmenting audio data, extracting MFCCs, and normalizing MFCCs. The dataset also contains visual features extracted from video data using the Open Face Pose Estimation Library, with only facial action units, FAUs, considered in this study. The proposed Tri-Modal model for detecting depression in clinical interviews integrates audio, visual, and text data. Audio pre-processing involves windowing and transforming speech waveforms into the frequency domain using a fast Fourier transform, followed by magnitude computation, filter bank output conversion, and Mel Frequency Cepstral Coefficients extraction. The MFCCs are then normalized using Cepstral mean and variance normalization to account for recording condition variations. Visual pre-processing involves segmenting video data to include only periods when the patient is speaking, slicing the data into 8-second segments, and normalizing continuous facial action units to zero mean and unit variance. For text-based model development, two-shot learning is employed with GPT-4 through the OpenAI API, where the model is given a prompt to classify the patient as depressed or not depressed, based on full text transcripts from the DAIC-WOZ dataset. The proposed model architecture consists of 7 steps, including extracting higher-level features from MFCCs using BiLSTM, dropout, and batch normalization layers, processing FAU data, and integrating the outputs with the large language model binary output. The final model is evaluated using leave one subject out cross-validation, achieving accuracies of 92.9% and 90.2% for the depressed and non-depressed classes, respectively. The model outperforms baseline and state-of-the-art models and is integrated into a locally hosted web application, DeepScope, for clinician use. However, the model faces limitations, including speed and deployment constraints due to large language models, and potential negative impacts on generalizability due to the small and homogeneous dataset used. Future work aims to optimize the architecture for increased accuracy and accessibility. This research paper presents a novel multimodal deep learning model for detecting and estimating depression levels in clinical interviews. The proposed model integrates auditory and visual cues, leveraging advanced techniques in speech recognition and facial expression analysis. The study emphasizes the importance of multimodal data fusion in improving the accuracy of depression diagnosis, as well as the potential benefits of using large language models to enhance the model's performance. The authors stress the need for a more nuanced understanding of psychiatric diagnosis, moving beyond traditional self-reported measures and incorporating objective, multimodal data. They propose an innovative approach to integrating various data sources, including audio and video recordings, into a unified model. This approach is expected to enhance the reliability and validity of depression diagnosis, reducing the impact of information bias and other methodological limitations inherent in self-reported data. The paper also discusses the importance of addressing potential issues such as confirmation bias and social desirability bias in psychiatric diagnosis. These biases can lead to inaccurate diagnoses and hinder effective treatment planning. By leveraging advanced machine learning techniques and multimodal data fusion, the proposed model aims to mitigate these challenges and provide a more accurate and comprehensive assessment of depression levels. Moreover, the study highlights the significance of using large language models in enhancing the diagnostic capabilities of the proposed model. These models have shown promising results in various domains, including psychiatric diagnosis, due to their ability to capture complex patterns in language and generate contextualized representations of spoken words. The paper also presents a preliminary evaluation of the proposed model using a clinical dataset. The results suggest that the multimodal approach outperforms unimodal models, emphasizing the importance of integrating auditory and visual cues in depression diagnosis. However, the authors acknowledge several limitations and potential avenues for future research, including the need for larger datasets and further exploration of various multimodal fusion techniques.